we are starting with more questions on composite shapes. That is part 4. Let's first look at the question. This time we will read the whole question and then we will do it parts by parts. A cylindrical open container, that's the one, has a diameter of 21. That means radius will be half of 21. And height 8 centimeter. Calculate the total external surface area. Part 2. A manufacturer receives an order for 3,000 containers. He needs extra 150 centimeter square of material for each container to cover wastage. Calculate the area of the material needed. And then a circular top that can hold 4 hemispherical bowls. So this is the place for 4 hemispherical bowls. Can be placed on the container. So now this is the circular top. Why? Because this is an open container. So that thing would occupy this much space. And what else is there? The top of the circle is a diameter 21 with 4 circular holes of diameter 7. So this is being carved out. A hemispherical bowl of diameter 7 fits into each hole. Well, it's a hole and we will fit in the not semicircle, the hemisphere in it. The cross section shows 2 of these bowls. So this is the cross section from the side view. It shows 2 of these bowls. Calculate the inside curved surface area of one of these hemispherical bowls. Calculate the total surface area of the top of the container, including the inside curved surface. With the top and the 4 bowls in place, calculate the volume of water required to fill the container. Now, it's a very, very comprehensive question. Let's start with each part. First of all, let me get the highlighter ready. So first of all, it's a cylinder. It's an open container. Diameter is 21. Height is 8. We are interested in the total external surface area. That means there should be the curved surface area and there should be the base area. There is no top. So first of all, total surface area is the curved surface area plus the base area. Curved surface area is 2 pi RH. The base area, that is pi r square. Let me take something common out, which is pi, which is r, which is 2h plus r. And now I'll plug in the values. This is pi, r is 10.5, 2h, that's 2 times 8 plus 10.5. We will use the calculator and we'll get this answer. I'll focus on the steps. So now I have left the answer in terms of pi, and then naturally I can use the calculator and get the answer in decimals over here. Now let's move to the next part. A manufacturer receives an order for 30,000 containers. He needs an extra 150 of material for each container to cover wastage. Calculate the area of the material needed to make these containers. Give your answer in square meters. Now, first of all, this time I need to use my calculator. So first of all, let me write this thing. That's 2 into 8, 16. 16 plus 10.5. That is 26.5. And 26.5 into 10.5. This comes out to be, let me write this, 278.25 pi, and which can be written as 278.25 into 3.142. This answer is in centimeter square. Now, we need extra 150 centimeter square for each container. So 278.25 into 3.142, let me evaluate it, into 3.142. We will use the unrounded value, which is 874.2615. This is the part 2 working. And let me add to it at 150. So if I add this thing, 150, So this becomes how much? This is 1024.2615 centimeters square. This is for wastage. This is for one container for 30,000. 1024.2615 into 30,000. We will round it off all the way at the end into, wait a minute, this is 1024.2615 into 30,000. This comes out to be 30727845. But I need to give the answer in square meters. This is centimeter square. We know that 100 centimeters is 1 meter. And then if I square both sides, so what do I get? 100 centimeter, the whole thing square, is 1 meter, the whole thing square. That is 10,000 centimeters square is 1 meter square. And if I take this value, which is 30727845 centimeters square, that becomes 307278.45. Actually, not 0.45. Let me write 45 first. And then let me write a decimal. 1, 2, 3, 4. This is 3072.7845. This is meter square. And then round it off to 3 significant figures, because that's the general rule. So first, second, third, and this is the fourth one. 3070 meters square. That is the final answer for this part. Now let's double check this answer. This is which one is this? I think I hope this is the right answer that I've plugged in. It doesn't seem like that. I think it is from some other question. Doesn't look like question number 7 over here. I think that's question number 21. Mistakenly, I took out question number 7. I can just fix it right away. So let's go to the past papers. And I can locate this thing, which is the topical book. That's right over here. And then question number 21, that is. So this is question number 21. There it is. And this is what I'll be pasting. So I've copied it. Going back to this one. That is composite 4. This is composite 5, and then composite 5 and composite 4. So first of all, okay. So let me just remove this. And let me paste it. Okay. So yes, this answer is 874. That's the answer for the first part. And this answer is 3070. That is perfectly good, perfectly correct. Now let's move back. Now this time, let's look at the second part. Now the question says, a circular top can hold 4 hemispherical bowls and can be placed on the container. The top of the diameter is 21 centimeter with 4 circular holes. I'm interested in this one for right now. And a hemispherical bowl has a diameter of 7 centimeter. The cross section is shown. Calculate the inside curved surface area of one of the hemispherical bowls. So the inside curved surface area is curved surface area, that is 2 pi r square. That is 3.5 square. So first of all, 3.5 square is 12.25 multiplied by 2. That comes out to be 24.5 pi. And this is centimeter square. And what else is there? Calculate the total surface area of the top of the container, including the inside curved surface area of each bowl. Now, first of all, let me just erase this thing and let me label this thing. This one is this one hemisphere. That's the other hemisphere. Then this is the third hemisphere. This is the fourth hemisphere. Now, besides this, what else do I have? I have this area that's right over here. And if I keep on going, so basically it's everything. It's the big circle minus these four small circles. If I look at it from the perspective that I am focusing on a two-dimensional figure. So I hope you are getting this, that this is the top, which is the big circle, minus four small circles. So first of all, let me get this green area. So if I'm talking about this green area, so this is area of big circle minus 4 times area of 4 small circles. That is the top area, which is shaded in green color. That is this thing. So first of all, this is pi, and this is 21 over 2 whole square, and this is 4 times pi, and this is 7 over 2 whole square. So 7 is the diameter, 21 is the diameter. So let me grab the calculator. 21 into 21, that's 441. So this is 441 over 4 pi minus 4 times 7 square is 49. That is 49 pi over 4. And if I do the subtraction, so let me write 4 into 49 instead of cancelling out. This is 441 pi minus 196 pi divided by 4. Let me simplify it as much as possible. 441 minus 196, that comes out to be 245 pi. This is 245 pi over 4. That is the answer for this thing. So this is 245 over 4 pi. That is the answer. But this is just the green area. Don't forget that there are 4 bowls over there. And this is the inside surface area. So add to it 4 times 24.5. So that is 24.5 into 4. That comes out to be 98 pi. And add this thing to this thing. So therefore, let me add 98 pi over here. That is the total surface area. So basically, this is the green area plus the inside curved surface area of one of these bowls. Since there are 4 bowls over there, we are multiplying it out. Yes, definitely you have to give the answer in a rounded off form. I am writing it in terms of pi. Now it says with the top and the 4 bowls in place, calculate the volume of water required to fill the container. Now, when we have the top in place, so top is this green thing, and the 4 bowls are these 4 orange things. Calculate the volume of water. Now, because of the top, the volume is unchanged. I'll do this whole working now. So top volume is unchanged. Why it is unchanged? Because it's a flat surface. So that flat surface, flat lid, that is causing no trouble to the volume. But because of the bowl, the water will be lesser. So therefore, that's 4 times the hemisphere, the volume of hemisphere. So that is 4 times. Volume of hemisphere is half that of a sphere, 4/3 pi r cube. Let me first simplify this. So therefore, 2 1s are 2 2s are 2 4s are 8. That is 8 over 3 pi r cube. And this is 8 over 3 into pi, and this is 3.5 cube. So first of all, 3.5 into 3.5 into 3.5, and multiplying by 8, and then dividing by 3, that is 114 3.33, multiplying with 3.142, multiply it with 3.142, that comes out to be 359.235 centimeter cube. This is volume of hemisphere. But it's all about the cylindrical container. Do we have the volume? No, we did not calculate it. We can calculate now. So now volume of cylinder is pi r square, that is 21/2 into h, which is 8. Let me evaluate this. 10.5 into 10.5 into 8 into 3.142. This comes out to be 2771.244. So the difference is the volume of water in the container. So that is the difference between this and this. This is also in centimeter cube. So 2771.244 minus 359.235. This comes out to be 2412.009. Therefore, let me write this thing as 2410 centimeter cube. That is the answer correct to 3SA. So let me double check this answer. This is 2410, and then the intermediate answers are there. That is still here. So that completes this question. Now, there is another question which is more or less along the same lines. So let's get started with this one. That was the whole question written together. Now let me get started with this one. It says the volume of a sphere is this much, the surface area of a sphere is this much, and it says a wooden cuboid has length 20 and 7 and 4. So that's the cuboid. Let me mark it out. That is 20, that's the length. And this is 7, that's the width. And the height is the green one, that is 4. And then say 3 hemispheres, each of radius 2.5 are hollowed out. So now, if we are talking about the hemispheres, now these hemispheres are there and they are carved out. And they could be asking us the surface area or the volume. First of all, the volume of wood in the block. So volume is 20 into 7 into 4. 4 sevens are 28. 28 into 2 is 56. That is 560 centimeter cube. That's the first part. But that is the volume of the cuboid. It's not the whole thing. This is cuboid. But we need to have volume of hemisphere first. So volume of hemisphere is half the volume of sphere. That becomes 2/3 pi r cube. Now plug in the value of r, which is 2.5. That is 2/3 into pi into 2.5 cube. Now let me grab the calculator. 2.5 into 2.5 into 2.5 into 2 into 3.142 divided by 3. That comes out to be 32.729 centimeter cube. This is volume of one hemisphere. But there are 3 hemispheres. So total volume of hemispheres, that is 3 times 32.729. Multiply it out. That comes out to be 98.1875. Now focus on the volume of cuboid. Focus on the volume of hemisphere. This has been carved out. A wooden cuboid has this length. Hemispheres are hollowed out to leave the block. Calculate the volume of the block. So just focus on this. This is the block. This is the block. So therefore, volume of the block, that is 560 minus 98.1875. Let's do the subtraction. This comes out to be 461.8125. That will become 462 centimeter cube. That is the answer for the first part. This is for 3 marks. Now it says the 4 vertical sides are painted blue. Calculate the total area that is painted blue. So these are the 4 vertical sides. That's one side. That's the other side with dimension 7 and 4. Then there are two sides with dimension 20 and 17, the front and the back. So 20 into 7 and 7 into 4. So this answer is very straightforward. That is 20 into 7 and 7 into 4, add it up and multiply it by 2, because there are two of each walls. So 20 into 7 is 140, 7 fours are 28, 140 plus 28, that is 168 into 2, that comes out to be 336 centimeters square. So that's another part. Let me highlight it. So this is 336, this is 462, this is part 1 that I have done. This is part 1 over here. This is answer of part 1. And this is answer of part 2. Now it says the inside of each hemispherical hollow is painted white. The flat part of the top of the block is painted red. Now let me change the color. It says it's painted white. So let me remain this thing, and this thing will remain as it is. So let's say that this is white. This is on the inside. So hold for a second. This thing is basically white. This thing is white. So I'm just cannot label it white. So this thing, the inside is white in color. And then what do we have? The top of the block is painted red. So top of the block that's painted red, that is this thing. This is the color, and this is red like this. So this is too thick. So all the way over here, like this. This is just like the previous question, very similar to that. So this is painted like this, and okay. So now, what can you do with this? The top area, the rectangle, that is 20 times 7. This is actually 20 times 7 here. And one more thing, I think I made a mistake. This one is 20 times 4. This is not 7. That will change. This is 20 times 4. That is 80. 80 plus 28. That is 108. And this is 216. Now, I just realized it once I was looking at the working. Why? Because we were talking about this thing. So this was 20 and this was 4, not 7. Now this 7 will be used over here. This is 7. This thing is 20. So 20 into 7, the rectangle area is how much? That is 140 centimeters square. And what about this is which color? This is red color. So this is red color, 120 into 7, but I'll be subtracting something. I'll be subtracting this white. What is white? The inside is painted this thing. Now, this is not exactly white. This is the 3 times the area of circle, because flat surface is a circle. So this is 20 into 7. This is not 120. Let me correct myself. So this is 20 into 7. This is 140 minus 3 times pi and r squared. What is radius? That is 2.5. So that is 140 minus 2.5 into 2.5 into 3. That comes out to be 18.75. And the value of pi is 3.142 into 3.142. Minus 140, subtracted from 140, that comes out to be 81.0875. That comes out to be 81.1 centimeters square. This answer is the red color. So this is the red color answer. And white, that is 3 hemispherical, this thing. So that is 3 times 2 pi r square. So that is 2.5 into 2.5 into 2 into 3.142. And this is multiplying with 3. That is 117.825. That comes out to be 118 centimeters square. So this is the white color thing that we were talking about. So the white color thing is this thing, not this one. That is like this. Now let's first check all these results. Just acknowledge on the WhatsApp that this is all good. First of all, A part 1, that's 462. Let me highlight it. So first of all, this is 461 or 462. This is 216. This is 118. This is 81.2. So this is all about the first part. So 461.7, which one is that? That is 461.7. That is this thing. Okay, this thing is all good. The second part is this thing, 216. I think that is also good. The third part, A, is 118, and this is 81.1. 118 and 81.1 and 216. So this is all good, all perfect. Now let's focus on the next part. That is this. Now the question says, the volume of water in the container is directly proportional to the cube of its depth. When the depth is 12, the volume is this much. Calculate the volume when the depth is 6, the depth when the volume is this much. This is not mensuration. This is proportionality. So let's solve this proportionality question. So volume is directly proportional to cube of the depth. So I'm using the symbol for depth as H. I'm using the symbol for volume as V. V is equals to KH cube. If I plug in these two values, 576 is K times 12 cube. So 576 divided by 12 divided by 144, this comes out to be 1/3. So K comes out to be 1/3. Volume is 1/3 H cube. Now two options are there. I can plug in depth. Volume is 1/3 6 cube, 1/3 of 216. So 216 divided by 3, that is 72. That is the volume, 72 centimeter cube. This is basically part 1. And part 2, volume is 1/3 6 cube. So, but this time the volume is 1300. I'm looking for the depth. 1300 is equals to 1/3 into H cube. 3900 is H cube. Therefore, H is cube root of 3900. So let me use the calculator. 3900, the cube root, that is 15.740. Therefore, this is 15.7 centimeters. That's the value of H. So this is 72 exact. This is 15.7, I think. Yeah, that is the answer. So that is about this thing. Now, let's look at this question. Now, let's do this question one by one. Actually, I would like you to try this question out first. Now, let's work this out. A, B, C, D, E are 5 different shaped blocks of ice stored in refrigerator room. At 11 p.m. on Monday, the cooling system failed and the blocks started to melt. At the end of each 24-hour period, the volume of each block was 12% less than the volume at the start of the block. Now, let's get started with the first part. It's talking about block A had a volume of 7,500 centimeter cube at 11 p.m. on Monday. Calculate its volume at 11 p.m. on Wednesday. So this is Monday, and then it's 11 p.m. on Wednesday. Now, if I work this out, first of all, 7,500 into 12% is gone. Therefore, 88% of the original remains. That is the first part. And whatever is left by Tuesday, again, 88% of that will be left. So I'm just writing it in one shot. This is till Tuesday, and this one is till Wednesday. So therefore, when I use my calculator, this is 7,500 into 0.88 into 0.88. This answer is 5808 centimeter cube. That is the answer for this part. Now, some people could be raising this question. Where is this 88% coming from? So this is 12% less. That means it is 88% of original value. So the original value is 7,500 centimeter cube, and I've taken 88% of that. So that is the first answer. Block A, 7,500, 11 p.m. on Monday, 11 p.m. on Wednesday. That's the first part that's done. Let's move to the next part. Block B had a volume of 6490 at 11 p.m. on Tuesday. Calculate its volume at 11 p.m. on previous day. That means Monday. Now, this volume is after the 12%. So therefore, it's kind of working in reverse. The volume on Monday multiplying with 88%, that will give me volume on Tuesday. Volume on Monday is what I'm looking for. 88%, I can write it in decimals, 0.88. Volume on Tuesday is 6490. So let's divide 6490 divided by 0.88. This comes out to be volume on Monday is 7375 centimeter cube. That is the second part. So this thing is done. Now it says part 3. Showing you're working clearly, find on which day the volume of block C was half its volume at 11 p.m. on Monday. So now I think I just got started over here. I had some extra space, no issue. So now it says half the volume. That means volume on any Monday into something 0.88, and we don't know how many times we have to do it. So this is 0.88 into 0.88 into 0.88. I'm unsure of that. So basically, it's kind of like trial and error. So first of all, if I multiply with 0.88, this is 0.88V. If I take 0.88V and then again multiply with 0.88, so let me double check, 0.88 into 0.88, that is 0.7744V. Again, another day, 7744V into 0.88. What do I get? Into 0.88, that is 0.681472. You have to show you're working clearly. 0.681472V into 0.88. Don't forget the V. That is into 0.88. This is 0.599695 and so on V. 0.599695V, 69V into 0.88. Multiply it again. That is 0.52773V. And I think one more thing, 0.52773V into 0.88. And let's multiply it out. That is 0.4644V. And we'll stop. This is Monday, and it's becoming Tuesday. This is at the end of Wednesday. This is at the end of Thursday. Every 88% of original, that is taking one day. This is Friday. This is Saturday. And last but not the least, that means on Sunday, it will be less than 50%, half its volume. So it's not in between the two. We are talking about one whole day. So by Sunday, it is 46% of the original. So this is 46.44% of volume of on Monday, not off, on Monday. So this is what you are looking for. Now let's first focus on this. So 7A, the three parts. The first part is 0.5808. The other part is 0.7375. The third part is Sunday. So this is Sunday. That is what we are looking for. So let's double check. So this is 5808, something like that. And this is Sunday. That is perfect. And this is 7380. It's a little bit unclear. So this is 7380, and this is all good. So this thing is done. This is part A. Now let's move to part B. Now the question says, volume of sphere is this, surface area of sphere is this. At 11 p.m. on Monday, at 11 p.m. on Monday, block D was the hemisphere with radius 18. Calculate its volume, calculate its total surface area. Now this is something basic. So this is volume of hemisphere. That is 2/3 pi r cube, half that of a sphere. That is 2/3 into pi into 18 cube. And you'll use a calculator and you'll get this answer. This is B part 1. And B part 2, its total surface area. So now this is a solid. It consists of the curved surface area. It consists of the base area. Curved surface area for a hemisphere is 2 pi r square. Base area is pi r square. This is, we are talking about a hemisphere. Therefore, total surface area is 3 pi r square. That is 3 into pi into 18 square. And naturally, you can use the calculator. You get the answer. The third part, part C. Block E. This is melted. Its shape was always geometrically similar to the original shape. It had a volume of 5,000 when its height was 12. Calculate its height when its volume was 1,080. Now the rule is volume of similar figures, volume of small, volume of big. That equals length of small, length of big, the whole thing cube. The original volume is 5,000. And that is the big volume. So let me write 5,000 over here. And the original height was 12. Let me write 12 over here. And then the volume is 1,080. That is the lesser one, 1,080. And length of small, length could be height also. The small height, that is HS. So therefore, cube is equals to 1,080 over 5,000. Now, first of all, what is 12 cube? So 12 cube is 1728. 1,080 over 5,000 into 1728. That is HS cube. So therefore, let me multiply it out. 1728 into 1,080. And this is how much? This is 1866240 divided by 5,000. This comes out to be HS cube as 373.248. Let me take the cube root. So HS, the cube root of this thing is 7.2. So HS is 7.2 centimeters. That is exact. Now, let me do one more thing. 108 divided by 500, and this is 0.216. Alternative way of working it out. 1,080 divided by 5,000. Cancel off the zeros. And this is 54. This is 250. This further cancels out. This is 27. This is 125. Now this makes more sense. Why? Because let me pick this thing and let me work it without the calculator. Maybe it can come in paper one. 1,080 over 5,000 is the small height divided by big height, the whole thing cube. This, after simplification, is 27 over 125. This is HS over 12, the whole thing cube. Therefore, 27 over 125 cube root is HS over 12. Cube root of 27 is 3. Cube root of 125 is 5. That is HS over 12. Therefore, 3 into 12 divided by 5 is HS. So this is 7.2. This answer is calculated in a different style. And that is the answer over here. I don't know why they have given a range, whereas the answer is exact 7.2. And this is the answer for the other part, which we did not use a calculator. So B